as in direction equals left for left in my link here. And I'm going to do the same thing again for right, up, and down, sort of, and then we'll process it in a little bit. And I just accidentally made a mistake there of changing the up to a D, and you'll see me make that mistake in a little bit. So, and I notice right there that something's peculiar, and I'm going to change it, and now it's fixed. I'm going to refresh and kind of wait for it to say, oh, this is a new link. Okay, now I'm set up. So I'm going to go forward and I'm going to do my processing now of what I've just accomplished. So at this point we're going to determine the new location based on relative location and direction, or given direction. And we're going to go forward and say if it is set that the request of D, and we're going to go forward and determine the direction that they gave us, and we're going to go and process it. So I'm going to go forward and scroll down and figure out how I'm going to write this, and I'm going to say, of course, the wonderful if, and I'm going to copy this request D because we're going to be using that. And if request D is equal to L for left, we're going to go forward and say that my new X in the session is going to be minus equals 1 because we're going to be going left 1, and left on the x-axis is negative. So we're going to kind of do the same thing, but to go right, and that would be plus equals 1 because to the right is positive and to the left is negative. And I'm going to do the same thing for the y variables here with the direction and position. And now I'm going to go and I'm kind of showing how at this point how the computer sees it as we go up we're actually going negative because 0 is where we're starting, and the computer sees it kind of in a flip view, so I'm going to swap this here and change it so going down is positive because the y coordinates kind of are swapped because of that, and now I'm kind of showing that now I've got this x so it can move around this table, but what if I keep going right and jump out of the house? Well, obviously we don't want that to happen, so I'm going to show that it can come back in the house, but the same thing kind of applies to going up and down, so we're going to need to apply kind of a secondary if in this thing here, and we're going to kind of put on boundaries, and I could use a second level if inside of this, but it's not really needed because we can put in a logical AND, which is kind of symbolized by ampersand ampersand, which kind of means and we're going to go on and say if the session of x is going to be greater than what it is, what the boundary is, so we're going to say greater than or equal to 0. However, in a bit I'll kind of make that mistake there of, well, if it's equal to 0 then we can still, then that still negative 1 happens to the x, so when it's at 0 it can go to negative 1, so I need to change it to to a to just a greater than instead of equal to, because then it only applies when it's 1. It can go down as, and can at most go down to 0. So I'm going to go on and kind of apply this rule to the rest of the if statements here, and do the same thing to the right, and you can see that I can go to the edge there, but I need to apply it, so I'm going to put a space before the and so that we have correct syntax. And I didn't change the greater than to less than, and but I'll fix that in a bit. And it's not doing anything now because I need to switch that to the greater than. Oh, and I need to change that to a less than. So here I am switching it. Now the reason why I did width minus 1 is because the width is going to 19, and the width that I have determined in the variable is 20. So I need to check it based on what we're representing in the digital data, which starts with 0 instead of 1. So I'm going to go on and kind of show here that if I applied this OR to it, logical OR is represented by 2 vertical pipes. It's on the same key as the backspace, as the backslash, which is under the backspace. And I'm going to kind of show this example a bit better up here on the left, where if I try going up and down, it's just going to go left each time because it's fulfilling the OR property, and it's still doing kind of like the left moving. So make sure that in the future, if you do use such things, you do not get them switched. It's not that hard to remember that ampersand looks like an and that means and. And I'm going to go on here and kind of apply the same thing to up and down in terms of boundaries, and change it to the height. And I'm going to look at this over here and point around and stuff. And I'm going to show you now that the boundaries work. So if I went up, I can't jump up out of the house, and I can't bury down the house, and I can't jump out of the right, and I can't really jump out of the left already. So I've kind of proven that what I've done works. And at this point, I'm going to cut because this part's a mistake. Okay, now that's cut out. So what I'm going to do now is kind of copy what I've already done here, but I'm going to process it in the opposite fashion of things. I mean, I still want to apply this left or right or down or up thing, but I want to retain the check on the boundaries. So if I'm hitting the boundaries, I need to say, sorry, but you just bonked your head. So I'm going to go on and kind of do something stupid here and